Welcome back to the training series for the Rehabilitation Cost Estimation Tool for Mining and Exploration in New South Wales. This is Module 13. The Underground Mining Area Input Sheet calculates cost for decommissioning and rehabilitation of surface infrastructure and land associated with underground mining operations. The sheet includes tables for disconnecting utilities, removal of conveyors, source and apply growth media and ameliorants, revegetation, maintenance and rehabilitated areas and repair, waste disposal and contaminated soil treatment. For costs associated with underground mine entries, including shafts, tunnels and adits, please review the video for Module 6, which is Infrastructure Mine Entries. To work through an example, let's say we have several underground mines that we want to show separately. The Disconnecting Utilities table has selections for major sites, remote sites, and underground utilities. In our example, we have a major utilities hub central to the mines and 3 separate mine sites. To make this clear, we will enter the hub serving the 3 mines to a separate column and add notes to the column saying Common Elements to Underground Mining Area Complex. We will then select Remote Utilities and enter 1 in adjacent columns for the 3 mines. For the underground elements, we have a quote of $90,000 for disconnection and making safe of all 3, so we distribute $30,000 as an alternate rate for each mine and enter a note for the regulator. We have conveyors for each mine, so we will enter those quantities in the corresponding columns. We have measured quantities of 1,000 meters for underground mine A, 500 meters for underground mine B, and 200 meters for underground mine C. This is all the entries for the underground mines themselves, and the remaining tables are for land rehabilitation, maintenance, and managing any waste and contaminated soil. We must enter the area for land rehabilitation for each mine, starting with the growth media. Underground mine A requires 10 hectares of land rehabilitation, mine B requires 5 hectares, and C requires just 1 hectare. As always for growth media, we now select the distance from which the growth media will come and the fleet to be used. In our case, growth media was stockpiled next to underground mine A, so we will select less than 200 meters. The haulage distance to the other mine sites is larger, and we will select 1,000 meters for underground mine B and 3,500 meters for underground mine C. For amelioration, our studies show that only the small mine needs work, so we will override the suggested area for underground mine A and B by entering 0 here. The whole area of underground mine C requires amelioration, so we will accept the area suggested by the tool, which is equal to the area we entered for growth media. Mine C requires the addition of gypsum plus biosolids, which is sourced from a local supplier within 5 kilometers of the mine. So we select gypsum plus biosolids and a one-way distance of less than 5 kilometers. The local supplier will deliver for $30 per tonne, so we enter that as an alternate rate in the buy section, and as the rate includes transport, we set the transport cost to 0 and leave a note for the regulator. We accept the cost calculated by the tool for spreading. The last land rehabilitation table is for revegetation, and the tool suggests the area based on the growth media area. We will leave these areas as suggested. The revegetation section for the underground mine area sheet has rolled up rates, so we only need to select from one drop-down. Our example is all pasture land, and seed will be applied from a dozer for underground mines A and B and handcast for mine C. For the maintenance of rehabilitated areas and repairs section, we have pest management to undertake on all 3 mines, and we will enter the total area of 100 hectares, which includes some land outside the rehabilitation footprint. We only need to enter this in the first column. We also have subsidence issues of 1 hectare associated with mine C. For the waste disposal table, we have some old oil storage that was associated with the general area, so we will enter it to the first column. We have 20 kiloliters, and it will be transported 50 kilometers to an oil recycler. We are in an area where the waste levy does not apply, so we select No Levy and provide a comment to inform the regulator. We have 10 tons of scrap steel near underground mine C associated with some old works, and it has to be transported 20 kilometers to a scrapyard. While we are in a no levy area, steel does not attract the levy anyway, so no levy should be selected whenever steel quantities are entered. We have 1 ton of PAH impacted soil associated with some old transformers in the hub area, and so we enter that here. As for all the sheets, the subtotals for each table are shown in the black lines at the end of each section, and then the total for each column is shown at the top of the sheet. The total for the sheet is shown on the left-hand side, and then above that is the total for the entire RCE, so that we can see in real time how quantities entered to the local sheet affect the total RCE. Let's jump over to the RCE summary to see how the totals are building up. We now have rolled up costs for infrastructure area, infrastructure mine entries, beneficiation facilities, tailing storage facilities, water management areas, overburden emplacement areas, active mining area, and now underground mining areas.